Hello everyone, and here's some hints on this assignment number 6. Okay, so first assignment, it's an Excel simulation example. Okay, I've given you a template. You can make use of the template to do the assignments. So the purpose of the assignments is basically to simulate the sample mean distribution, okay, based on a very simple example. The population consists of only 4 numbers, 2, 4, 6, 8. And now you're going to take 2 samples out of the population and then calculate the mean value of the 2 samples from the population. And then we're going to look at basically what does the distribution look like for the sample mean. Okay, we have theoretical formulas for calculating the mean and deviations of population. We also have the formulas for calculating the sample mean as mean and the standard deviation of the sample mean. Okay, so you're going to be able to make use of this to simulate and verify if the formulas are right or not. Here's the Excel that I give it to you in here. Okay, so basically I didn't include all the information, but this is what happens. You have four outcomes in the population. Okay, 4 objects. So you're going to take 2 out of it. Now the 2 here, order doesn't matter, and it could be repeated. So basically, you can take a 2, 2. You can take a 4, 4, like that. You can take a 2, 4. You can take a 2, 4, 2, right? So I want you to list all the possible samples, okay, of 2, size of 2 out of this population, and calculate the corresponding mean value like this. All right. Yeah. Bottom line is, okay, and this is basically a permutation problem, which with allowable repetition. So basically, with repetition allowed. Okay, so in the class, I don't think we covered this, but when you have a permutation with repetition, okay, allowed, okay, for example, you have n objects, okay, and taking, okay, r at a time, okay. Yeah, so in this particular case, okay, we have 4 objects where we have taken 2 at a time. Now actually you take 1 and then you put 1 back and you can take another one. So basically but repetition is allowed. In this particular case, the formula is the number of possibilities is n to the power of r. So what you have here, it should have 16. Okay, so if you go back to the Excel, so there should be 16 of them should be listed over here. Okay, and then the next thing you do is, you know, each time you have a mean, then you calculate, okay, what is the mean value of all the sample means. Okay, so this value here should be the same as the mean value of the population. Okay, so population mean is 2 plus 4 plus 6 plus 9 divided by 4. Okay, and this value over here should be the same as that. Okay, you can also calculate the standard deviation, okay, based on these numbers here. Okay, and this is not going to be the same as population standard deviation. Okay, it's actually going to be small, okay, smaller. So, and then I want you to plot a histogram, okay, for the sample means. So what you list here is you list being here. Okay, basically you list all the possible mean values. So the mean value could be 2, could be 3 or 4 or 5, you know, could be 6 to 8. And then, okay, we calculate the frequency, okay, for each one of the sample mean within these numbers here. Basically, the formula is given to you. All you need is, okay, fill out this column here. You'll be able to generate the frequency distribution will be generated. Okay, If you wanted to manually put this one here, here's what you can do here, okay? Yeah. So if you look at this cell here, I have a formula called frequency from B5 to B20, and then the population there is the B number here is E5 to E11. So basically, if you want to do it from scratch, you can copy this one here, okay? And let's say I'm going to do it here, so just paste it here, okay? So yeah, this number is not going to be right because I didn't fill out all the form and all the cells that are here. And then, okay, you select, okay, from this cell up to here, all right? Okay, and then you press your F2 key, your function F2. Okay, so F2. So here's my F2 over here. In your keyboard, press F2. And now what you do is you press Control Shift Enter. Okay, all together. Control Shift Enter all together, and that'll fill out from here to here the frequency distribution of each one of these numbers that are here within B5 to B20. Okay, yeah, so that's gonna be how you do. Okay, so now you will create a histogram based on, or you can create a histogram basically here. So what you can do is this is what it's gonna look like, but I think in the class I demonstrated how do you create a histogram. But the first thing you need to do is there's a data here. There's a data analysis tools. You may not have this. Sorry. There's a data analysis tool right here. Okay, under data. You may not have this one in here. Because basically there it's not enabled. Then what you do is you basically go to Excel option. Okay, go to addings in here. Okay. And over here there's Excel addings, and here you click go and check this analysis toolpath and click on OK. Okay, so then you will have this one show up here. So then what you do is you click on it, choose the histogram, and OK. So within this input range, and you select from B2 to B20. So anyhow, you select that, and then from the bin range, you select from here to here. Okay, and then you can click on chart output in here and just click OK. Okay, so then the histogram will be generated for you. All right, yeah. All right. Okay, so I want you to practice this. Okay, so it's a good exercise. So that's the first question. Okay, so let's take a look at the second question. So the second one is basically calculate the z-score, okay, and calculate corresponding probability. So what do we have here is the population mean, and the population standard deviation, and you have the sample size, and find the probability the mean of the range between 96 and 106. So let's say if you define a random variable, let's say in this case we're talking about sample mean. So basically we're saying is sample mean x bar, right? Between 96 and 106. And what is the probability of this one here, basically? All right. Yeah. But in the class, I said you generally don't calculate like this. You calculate the z-score. Okay, the probability of the z-score of this one. So the probability for this one, right, equal to, you convert, okay, this guy into the corresponding z-score. Okay. So what would be the z-score, z1, z2, corresponding to 96 and 106? Now this capital Z here is a standard, okay, standard normal variable, and which you have a table, okay, and you can make use of table to look for corresponding probability. The z-score, just to move this down a little bit. So the z-score for the sample mean has a normal distribution with a mean of mu and a variance of sigma squared over n, right? So the z-score for this one is x1 bar minus mu over sigma over square root of n. Okay, so this is how you calculate this z1. Similarly, this is how you're going to calculate z2. Okay, so 96 is here and 106 over here. Okay, so mu and sigma are given. So then you can get z1 and z2. So you can now make use of your z table to look for the probability. Okay, so anyway, so this is going to be negative 2.25. This is going to be 1.5. Okay. So I think you know how to use that table to look for the probability. Okay, yeah. So try it out. Just use Z table. Okay. Third question. Average annual Canadian consumption of red meat is almost 63 kilogram per person. It's quite a bit of red meat. Assume a standard deviation of 7 kilogram and an approximated normal distribution. Find the probability the person selected at random consumes less than 60 kilogram. And then if a sample of 40 individuals is selected, find the probability that the mean of the sample will be less than 65 kilogram per year. And the common difference. Okay, so the first question is basically you select a person and you can define, let's say, you can define random X as a consumption of red meat. Okay, I'm not sure what I'm writing here, but okay. Okay, so then for A part, basically you're looking at what is the probability for capital X is less than 65, right? So this is basically the first one. And capital X has a distribution of approximately normal, so then we don't calculate the probability, we calculate its z-score, right? So we calculate the z-score, the probability. And the z-score for the z1 is basically it's capital X minus mu over sigma. Okay, so in this particular case, small x out here, okay, and small x is 65. Okay, so you calculate that, and then you go to your z table. Okay, look for the probability of this. Okay, so the part B is different. Part B is you're taking sample 40 and then you calculate the mean to find the probability the mean of the sample be less than this one here. Basically you're looking at what is the probability of X bar less than 65. Okay, yeah. Again, you don't calculate you don't calculate like that. You calculate first the z-score for the X bar, right? Okay, so the z-score for the X bar is 65 minus mu over sigma over root n. Okay, so then we try to calculate what is the probability of capital Z less than that. Let's call it Z naught at here, right? Yeah. So bottom line is, I think the first one you will get. The first one you will get is the first one you get at 0.6179, and the second one you will get is 0.9713. Okay. So what this tells you is the probability for sample mean to be less than 65 is much higher than when you sample just one consumer, which is less than 65. So what's the reason, right? What the reason is actually, if you recall that, basically, the reason is basically due to what is the variance, or what is the standard deviation for the two random variables. The variance for this random variable capital X is basically the population variance, and the variance for the sample mean x bar, it's not sigma square, it's sigma square with root means, right? So variance for capital X is sigma square, and variance for x bar is sigma square over root m. Okay, so apparently the variance for the sample mean is much smaller than the variance of the population, and this is why, okay, the second probability, giving the same number, is much higher values than the first one. Okay, yeah. So that's the third question, and the fourth question. Assume the sample variance to be continuous measurement. Find the probability that a random sample for 25 observation from a normal population with this will have a sample variance s squared greater than that, less than this. Okay, so now we're talking about the distribution of a sample variance s squared, right? Okay, so the first question you're saying is, what is the probability of s squared greater than 9.1? Okay, so in the class we mentioned about calculating this probability is equal to calculating the probability of this. So essentially, it's like a linear algebraic manipulation. You multiply s squared, multiply both sides with a minus 1, and then divide both sides by sigma squared, right? Okay, so and what this side here, what this side here is basically, if you recall, that's a random variable called chi-squared, right? So this one has a distribution of a chi-square distribution. And then for this particular case, we'll be able to make use of a table, okay, to find this probability. Okay, yeah. So let's look at the table maybe. Okay, let's look at the table. Okay, so this is chi-squared table, and you've got to be careful is, okay, look at how the table is given. So basically, for any particular value, chi-square value, you're talking about whatever this chi-square value and this alpha value. So that's the area to the right has that much of a probability, right? Okay, so in this particular example, you can calculate. I think this is going to be 36.4. So we're looking at the probability of chi-squared greater than 36.4. Okay, yeah. So let's see what is the area. Let's look at the chi-square table. Okay. So okay, first of all, what's the degree of freedom? 25. So 25, and there's a degree of freedom of 24. Okay, so 25 observation, v equal to 25 minus 1, 24. So if you go to degree of freedom 24, okay, and look for the 36.4, so right here. Okay, so this value corresponding to an area to the right, okay, 0.05. So that means basically this is what you're looking for, right? So you're looking at this greater than that, so this just equal to 0.05. Okay, so that's how you make a look for it. And similarly, you can do it for the part B. Okay, yeah. Just transform that. Problem number 5. Okay, yeah, I think problem number 5 is not that tricky. Probably part D is a little bit tricky. So first one is simple. Just simply look for tables, right? Just simply look for tables. So look for the T table. Okay, so how many degree freedom do we have? We have a degree freedom with 14, and you're looking for this T value. And this T value, if you look at this T table, so when you have this T value with the subscript alpha, so that means that's the T value corresponding to which has a area of alpha to the right. Okay, so T0.025 means the T value that has a 0.025 of area or probability to the right. So looking for 14. Okay, look for 14. Look for 0.025. So 14 is over here. It's 14. And 0.025, which is here, so the corresponding T value is 2.144, right? 2.145. Okay, so that's basically how you get that. And to find negative this, so T distribution is a symmetric distribution, right? Symmetric distribution, and when you talk about the T 0.1, so T 0.1, maybe it's here. So there's 10% of area to this right. So negative, so it's because it's symmetric, so the negative T 0.1 is going to be here, right? So first find out what this value is, then just put a negative sign, and that's going to be this negative this. Okay. Okay, so I think you can find that. The third one, which is also simple. So it's the two T values are given, and you try to find a probability for random variable capital T between these two. So what you do is basically you need to find for the C part. So what do? You need to find what is the probability. So I need to find what is the probability of T less than this, right? And what is the probability of T less than this? Then overall, right, the probability of this, right, will equal to this minus this. Okay, equal this minus this. Okay, so okay, and minus probability less than this. Okay. Yeah. Still, you make use of the table, but however, when you make use of the table, you're going to be careful because basically the what the table here. You look at the table here. What the table is giving is probability when T is greater than certain value. Okay, that's what the table says here. So now, if I look at this one here, let's see what is the probability for T less than 2.179. In the table, right, what you find is, right, from table, okay, from table you can find probabilities for T of this. Right, so let's see what is that equal to. Degree freedom is 12. Okay, degree freedom is 12. 12 is 12. 2.179, which is here, and the alpha value is 0.025. So to the right is 0.25. So this is 0.025, right? So then probably less than that, that's basically equal to 1 minus 0.025. Okay, yeah. Similarly, you can find probably for this, and you find probably for this C. Okay, let's look at the D part. Okay, okay. D part. Let's draw the distribution first. Okay, 0 right here. So now what do we have? We have probability negative 2.069 TK, okay, equal to 0.965. So you're looking for what will be the value of the K at here such that this probability equal to this. Okay, so first of all, find negative 0.69 here, and maybe there's a K over here, right? In the middle of here, you have the probability 965. Okay, yeah. Okay, so let's see. How about from the table? What do we get for the probability of negative 0.2, negative 2.069? So the probability of this, right, equal to the probability for t less than k minus probability of t less than this, right? Okay, yeah. Okay, so I guess in table it doesn't have negative 2 points, but in the table you do have 2.69. Okay, so you look at the table here, degree of freedom was 23. So degree of freedom is 23 at here. So go to the table, 23. Okay, 23 over here. 2.69 is right here, and alpha value corresponding to 0.025. Okay, so the probability for t greater than 2.06 is 0.025. Okay, so where is 2.06? Maybe somewhere here, right? Greater than that. So that means this value, right? Yeah, this value basically is actually also same 0.025, because to the left side here, okay, is 2.25. So overall, we're looking for probability 0.965. So that means what? That means the probability of this guy should equal to, so that means the probability of this should equal to 0.965 plus 0.025. Okay, yeah, right, and which is 0.99. Okay, so now the question is, what value of k will give us 0.99? Well, again, the t table doesn't have anything probability of less than certain value. What it gives you is the probability of a certain t greater than certain things. So that means in the table, right, from the table, right, look for probabilities of t greater than k equal to 0.01. Right, find that key value, okay, and that'll be this, basically corresponding to this case. So let's see what value gives 0.01 for 23 degree freedom. 23 degree freedom and 0.01, right? I did the fourth column. Fourth column is right here. So 2.499, so 2.5. So the key basically 2.5. Okay, yeah. So it's a little twist in terms of looking for tables, right? But if you look at Excel, it's probably more easy using the Excel formula. But anyway, I want you to practice using tables. Last question. Okay, so manufacturer claim battery used in their electronics scheme will last over 30 hours. To maintain its average, 16 batteries were tested. If the computed T value, okay, falls between this, okay, then you're okay. Your claim is satisfied. Okay, so now given this specific sample values, what would be your conclusion at here? Okay, so first of all, degree of freedom is 16 minus 1, okay, 16, 15, okay, and since your standard is between these two t values, right? So you need to look for what is this t value corresponding to this degree of freedom, and with an alpha value 0.025. So you can find that as 2.131, and the negative of that will be just negative 2.131. Okay, so what you need to calculate is you calculate the t value corresponding to the sample, see if it falls into this one. Okay, yeah. So what's the t value for this particular case? The t value, right, as we learned, is the formula is this. Okay, so here is your population mean. Okay, here is your sample mean. Here's your sample standard deviation, sample size. Okay, so you calculate this. So -2, and that's the value between these two. So then your conclusion should be a yes. Okay, yeah, that's valid. All right, so that's all for this assignments. Okay, so not much calculation. Okay, make sure you understand the concept, understand how you look for tables. Okay, and you should be okay. All right, thank you.